Okay, so we talked a lot about configuration, and I was showing some state in there as we were going through, but not a lot of it. I want to kind of focus on state now a little bit more. So we have this nice dashboard here, and it's telling us a lot of very abstract information, like what does a fabric being up even mean, right? And a fabric doesn't have an operational state necessarily. What it actually means is all of the underlying resources are up, right? This is kind of the benefit of having abstractions layered on abstractions. What a fabric being up means is all of the default interfaces, you know, the sub-interfaces attached to the default network instance, they all have to be up in order for the fabric to be up. I also need all my default routers, you know, the default, the GRT network instance on the devices to be up. I also need all the inter-switch links to be up. I also need all the BGP peers to be up. So all of these things have to be true in order for the composite state of the fabric to say up. And if it's not, you'll get to a state where it says it's degraded.
So there's actually, yes, the thing about operations and monitoring, does this replace my monitoring systems? Is this just what it needs to know for in here, but I would still use my other tooling? Like how do you see those things interacting?
Our goal is to replace your monitoring system. I think you get the best operational experience if you can see the abstractions and the configuration, and then you can see the state of those abstractions and observe it in a way that is very, very easy to consume. Yeah, I would say our goal is to replace. Obviously, you don't have to.
So I like, you know, in a previous life, I was consultant for HP OpenView network management a long time ago, you know. But then in the days when you had a big tool that did one thing,
yeah,
and obviously, you know, that doesn't really work these days. And I love it these days that I can take a bunch of different things and glue them together, and classically put something like Grafana at the top level of that, because Grafana is great for pulling all these things from different locations. Because the things, so when I look at this, I say, well, that's probably great for operational stuff about my network, but I don't really care about the network on its own. The network's doing things for me.
It's more about a part of your solution.
So, you know, I'm just trying to sort of get it right in my head as to how this interacts. It's probably, okay, when I'm looking at, say, the fabric stuff, yeah, I probably do want to be looking in here, but I probably want to be pulling information out of here, and
which you can absolutely do. Yeah.
Somehow integrating that with other things. Some other thing.
Yeah. So we support both models. You can either we actually have a couple of apps. I don't know if you're gonna. No, you're not gonna play with them in the hands-on, but there's an app in our app store that deals with exporting stuff to Prometheus. If you're using Grafana, for example.
Yeah, Prometheus is one of the tools that we use a lot.
So you can grab all the telemetry information, like fine grain. You decide which tables you're interested in, and we will publish them, either push or you can come and scrape us. Both models are supported to feed into your northbound system. So again, it's one of those. Obviously, we have ambitions. We think there's a better user experience if you use this as both a kind of a configuration platform and the observability platform. We cannot mandate that you do that. We have to support all cases, right? Everyone is going to have a tool chain they're already familiar with. So we need to integrate with that tool chain. That being said, I think there is a ton of value, maybe just for the networking stuff, in using this, because it gives you these kind of like high level, is my fabric up? Yes, it is. If we look at like BGP peers, we even do things like publish health, for example. So, I mean, here my health is 100 because everything's up, but you can kind of get very pointed, this is your problem, if you use this as your observability platform. Those apps can be the ones to figure that out.
There's obvious one there, you know, like interfaces up, down, BGP peers or whatever.
Yep.
Things I worry about are things like light levels and optics, error rates, those sorts of things, you know.
Yep.
You know, and that's not coming from my fabric definition as such, you know, but that's some of the operational data that's relevant to the operation of that fabric.
For sure.
You know. So
now, unfortunately, this is a sim environment. There's no optics here for me to show you, but you're giving me a pretty nice segue into the next part of the presentation, which is nice. So yeah, we were looking at a dashboard, and it has a lot of abstractions, right, on the health of things. Are things up? Are there any alarms? The counts of various things. And we have a chart down here that's going to graph the total number of routes that are present in the fabric. So it's very, very abstract. Now, I'm sure there's a bunch of operations people that are like, I can't debug anything with that. Like, there's not enough information there. So we wanted to give you, I mean, the nice thing is we're in this world now where everything is model-driven. We have Yang models. So why not let you query the entire surface area of every underlying device you have in one place, right? That is kind of the next part of our demonstration here. which is queries. So I do have some saved, which I'll look up in just a second. But to get us started here, we actually expose the whole surface area of the schema for you. Like, let's say you were interested in light levels. I think light levels are somewhere in interface, adapter maybe. What's in there? No, there's nothing in there. I'll have to go for, well, actually, there's a spoiler coming soon. So you have access to the entire data model here, right? So in SRL, one of our top level things is interfaces. So I just want to grab interfaces. What happened under the hood when I hit enter just then is our controller reached out to all of the devices that matched this, which I didn't add any extra constraints, so that was every device, and pulled in, like did a streaming subscription, and then fed that back up into my controller. And that all happened in like a fraction of a second. So we can extend this. Actually, I will pull up my notes here just so I don't go too far off script. And actually select certain fields. So I might be interested in opera state, and I might be interested in admin state. I might be interested in, what's another one? I think I'm going to use last change. So now I'm only getting those 3 fields. So you can very, very quickly fine-grain, grab things that you're interested in. I can even start adding where conditions to this. So if you've ever used Jira, this query language is kind of loosely inspired by the Jira query language. But the cool thing here is like everything is live streamed.
Something you want to admit?
I mean, I said loosely, loosely inspired. Where admin state is equal to...
I have my battles with all the QLs though, so like prom QL is one I...
Yeah, prom QL is pretty nuts.
I can do everything, but...
Yeah, so pretty complex query, right? Like I'm just grabbing fields and stuff. We can even build up the complexity even more, and we can order it. I guess I can just write that. Order by, I'm interested in last change, because I want all the interfaces that are changing at the top. Now, the nice thing here is you can see like we have the count of the number of nodes that are reported in. All the data you're seeing there is actually streamed to you, right? Not just once. It's actually live streaming right now. If those fields were to change, those fields would update immediately. And just to prove that, I'll grab this query. Now, this is going to be a little more complicated. I'm grabbing some fields and I'm summing them. So we've even got like some actual SQL in here. And as you can see, I'm sure the live stream is not going to pick up how fast those counters are changing, but they are changing really, really fast. And that query is basically figuring out bits in, bits out, network-wide, just with that one query, right? And obviously, we can then throw that into a visualization and line chart it.
So, I mean, that's like looking at interface counters. It's kind of dull on its own. It's only really useful when you're looking at that rate of change over time.
Mm-hmm. Yeah.
So, let's say, oh, that's good. I want to see that, but I want to see what that looks like over the last hour.
Yeah. So we have 2 things coming near the end of this year. One is for us to actually compute rates where the device won't compute the rate for you. This one's actually nice. Like SRL computes the rate for you, so I just need to grab it. But it's figuring out the window for me. A lot of fields don't, right? They are just continually incrementing fields. Yeah. So in 2411, we're going to add the ability to do rates. And obviously, there's a TSTB aspect to this as well, which is also coming. Everything you see right here is just like live. It's raw data being fed to you. Right now, you dump that to Prometheus, and then you kind of have your historical data. Most customers are happy with that. But we see value in being able to see the historical data in the UI as well.
Yeah, because, going back to say that light level one, that's something I think about. But the light level ones, like I want to know at an instantaneous basis. So I have a POMQL query that I'd write, which is something along the lines of, show me all the interfaces with light levels less than, let's say, neg5, with interface class this, which is based on some other things, and with interfaces up, because don't bother telling me for the ones where I've got nothing plugged in on the other end. I've got string together a bunch of things, and it shows me that, and that's like great. Here's the ones that got low light. But the ones that were much more interesting to me is, where's one where the lights decline by, say, more than...
Yeah, there's a rate of decline over time.
Last month. Because this is a classic thing I get. Is something you'll see an interface start erroring or go down, and then you look at the light. Oh, the light level's okay. Oh no, wait. When I look at it over a month, it's been just slowly dripping.
You know it's going to fail.
Yeah, failing optics.
Yep.
Yeah, so those are the interesting ones to me.
Yeah, so I mean, right now it's all raw, so you could feed this into your Prometheus stack and do that stuff. We are adding that functionality at the end of the year, so you'll be able to do that natively inside of Vita.
Cool.
Okay. moving on. So EQL is pretty cool. The EDA query language, that's what that stands for if you were curious. But we would be pretty remiss to not have some AI stuff in our controller in 2024, right? Of course. So I have some queries that I baked here earlier, just so I don't have to type them all out. We don't actually have to learn EQL. You can just talk to us in natural language. List all switches sorted by CPU utilization with most utilized first. And we will figure out the correct query to run, and we'll return that to you. So you see, we just figured out that, oh, there's a CPU table, and I'm interested in the actual total CPU, and I'm interested in the instant field, and I'm going to sort it descending. That is what that query figured out based on that input. So you can see, actually, you can see it's live updating too.
So that underneath it, it's given you...
It told us the query that it would run. And if you wanted to, you can actually like pop it up and start editing it if that's a good starting point for you. But yeah, exactly. It figures out the query just based on, I mean, this is using OpenAI.
Yeah, that's really helpful to turn that, to not just leave it as the natural language one, but to give you that, the query language one.
Yeah.
Because
learn it.
chances are high that that natural language one hasn't quite got what I want, but it's also quite hard for me to figure out
it's probably in the right ballpark, right?
So,
yeah. Yeah, it's almost like we have product managers that work on this product or something.
Now you have some assumptions in there, like you didn't tell it, here's the interval for you to update.
Exactly.
Where do those base assumptions come in for stuff like that?
Yeah, so I mean, you could actually extend it. You could write those in, but we basically have a prompt that we give, and we bake in a bunch of this stuff. Like we have to basically tell the LLM, this is how you structure EQL, right? Here's the available tokens that you have. And then we actually need to give it a best match table that we pick, because obviously we're not going to give the entire schema of all the devices to this language model. We're going to burn tokens faster than we can imagine. So we actually need to do a local lookup first and say, here's the query based on my local vector DB. What is the correct table most likely? I'll grab the top 10, and then I will return the schema of those tables for the LLM to be able to figure out the correct table to query. So yeah, there is some pre-baked assumptions just in the prompt that we give. So let's look at some more interesting ones. Did I actually paste that? I didn't paste it. So this one is just going to show you any interfaces with error counters above 0. Actually some in there, which is nice. So, but it's giving me a lot of other information, right? So let's actually refine that a little bit. I'm only interested in error packet fields, and I want to sort by most errored packets. It's going to go away. It's only going to grab the fields that have errors in them from that table. And then obviously sort them for me. I only have one interface with errors. So now on the security side, you can ask it questions like, show me all network instances with MAC duplication detection disabled, because that would be bad if you didn't have that enabled. I don't have any in this topology, but you can see I got the query correct. And some maybe more interesting stuff. You can actually use this to find addresses. So show me the node with an interface that has an IP of this specific IP. And it actually figures it out that IP is on leaf 16. It's the loopback address on system 0. You can even interrogate the fib with this. So I'm going to ask it for find the fib entry with prefix 11003.
I think we're going to need a bigger text box here.
Show me which network instance it is found in and the protocol over which it was learned. And you'll see that we get a bunch of entries here. There's the host entry, obviously, which is on leaf 11. And then everyone else is learning it via BGP. So kind of what you would expect to see here in a fabric. And we can actually get that similar query that we had before. Here I'm only counting number of packets rather than bits. So that's your packet rate in and out, network-wide, where you just ask the question in natural language. So you can see it's just incredibly powerful, right? You can query the entire surface area. Basically any field, a node that we're talking to is exposing, you can now query using this query language. But one cool thing about language models is they don't have to speak English, right? So show me up interfaces on leaf 11 in Spanish. I don't know if this works. I'm winging it here. Look at that. Oh, I didn't get it fully correct. They're not up.
Bueno, amigo.
But yeah, it's grabbing me interfaces on leaf 11. I can even do something crazy. Any bets on whether this is going to work?
How would we know?
Oh, I didn't get the up again. I'm going to turn it to operational. Maybe that'll translate better into Japanese. Try again. There we go. Operational, better than up. So you can speak to the controller in any language you like.
So you changed that to operational.
Mm-hmm.
How did you know to change that to operational? Like if I typed in that query and it didn't give me what I was looking for, I would be like, okay, what else could I have typed?
Well, this is the whole like why seeing this query here is important, because it isn't a case of necessarily that you don't know that that query is accurate. You just don't know that that's the correct query to write, right?
Yes, yes.
So, I mean, just like any LLM, they will hallucinate. You potentially will get answers that aren't correct, but it will roughly get you in the right ballpark so that you can then evolve the query, kind of like Lindsay was mentioning before. So you could say that it wasn't grabbing opera state up. That was how I knew that it's not recognizing the word up, obviously. I should change it to operational. But that was a guess. I mean, I had no idea that was going to fix it.
Can the system guide you for that? Is there a way for the system to be like, well, what you said was this, but what you probably should have said was this?
Yeah, so what you can do is do kind of reinforcement LLM queries. So when you get it back, you can actually ask it again and say, does this look correct? And it will say yes or no. And then you can follow up with, okay, I picked the wrong table. I'll pick the second table this time.
Is there a way to train the system to learn what up means?
Yeah, for sure. I mean, I could teach it that and recompile things, and we could run that query again, and it would work.
Hollingsworth, tell me what interfaces are.
Well, I was thinking more along the lines of a manager who just assumes that that is the word that we've always used, and therefore that is the word I'm going to use, and I don't care if your system doesn't recognize it. You need to make it so that it does, because I'm never going to change the way that I do things.
Yeah, so to be fair, the only reason it didn't recognize it is because I translated, right? Like if I actually said that in English, it would have got it correct. It's the translation that's really the problem, not necessarily the natural language itself.
Well, but the reason why I'm asking those questions is because if this is supposed to be an extensible interface, we change the definitions of things constantly in how we reference stuff. And I feel like if the system is still hidebound enough that it won't recognize when I'm using a non-keyword term, it's no better than the current system that I've got where I have to question mark after every argument in a command in a CLI to get the right way to say it.
Yeah, so you can change that prompt. So you could say, in fact, I mean, I can show an example. Mike is going to love this. Show me interfaces. Is he still here even? I don't see him. Show me interfaces with Riz.
Yeah.
Because what does Riz mean, right? I actually didn't know this. Apparently it means charisma. It's the teen speak for charisma. So show me interfaces with Riz. Now Riz, I think, means up. So I told the controller, if someone says Riz, it means up. And obviously, if someone shows me interfaces without Riz, those interfaces are probably down, right? So absolutely, you can teach it your own language. And our controller is a teen.
Very Sigma.
It's the
I mean, yeah, I'm glad you asked that question. I wasn't planning on showing that, but
Hey, Bruce.
yeah.
Maybe it's my time at a knock, but you know, this is an operations story, right? Like, I'm trying to think of how the break fix folks interact with the system. So is there, you know, I would have an NMS and it would pull SNMP traps and it would tell me things are broke. It's very reactive, which isn't great, but that probably needs to exist as well. So if a leaf falls over and dies, do I have a dashboard? Am I using an NMS in addition to this? Am I setting up rules to spit out a ServiceNow ticket? Like, how do you foresee?
I mean, we provide all those dashboards, right?
Okay.
So they're all baked into the product. We don't expect you to have to go outside of our product to know that a node.
So I'll have a screen to tell me like, hey, something's on fire.
Yeah, exactly. I mean, we have like the kind of the nice summary here on our home dashboard, which is telling you like the number of nodes, are they up? The number of interfaces, are they up? Traffic in and out, network wide.
Dashboard, actually 292 critical alerts.
Yeah, I mean, it's a real topology.
Yeah.
And we don't simulate the transceivers, like I just said, so all the transceivers are down. That's why we have all those alarms.
But I can query my physical infrastructure. Like if, you know, like you said earlier, you know, BGP down or, you know, is the fabric up? Like, I'm more interested in what he's saying, like, is an SFP failing or did a circuit bounce or...
You can ask all those questions.
That's in here, right?
Of course. Yeah, of course.
how much of that is requires customization or is baked in?
None. I mean, the common cases of like, I just want to monitor nodes, I want to monitor interfaces, BGP pairs, how much are up, how much are down, and drill into which ones are down. All that is here today, right? I mean,
bad things happening. This will.
Yeah. So you shouldn't have to leave our controller to understand any of that. We have our own alarms, obviously. We can go look at those. Like we have a bunch of alarms in here as well.
That's probably what I was getting at, right? Okay.
Yeah.
You can filter the alarms, obviously. And
obviously.
Yeah.
Yep. So maybe I'm only interested in ones that aren't cleared, for example. That gets us to our 292 count that we had on our dashboard there. Cool. So yeah, I mean, it is kind of like a one-stop shop is the idea, right? We want it to kind of be the true single pane of glass for infrastructure automation. And that means we can't just do config. All of these kind of operational use cases, the platform has to be able to support as well. Okay. I thought Tom was going to like interrupt me there. He's standing on the side ominously. I still have 20 minutes? All right, that's fantastic. So next we're going to move on to operations. And since we talked about building dashboards, let's build a dashboard, right? Really quick. Now, I will motor through this just for the sake of time. I need to change menus here. Actually, we'll do it over here.
Just one quick question on the natural language query before we move on here.
Yeah.
That's all running locally. Does it have to reach out to the?
It does. Yeah. So we don't expose data to the language model. We expose schema, so it understands that it's an SR Linux table. That's all publicly documented anyway, and it will know the question, but it doesn't get any other information. So it never gets state or anything like that. That all happens kind of locally.
Oh, okay.
Yep.
And then when you're training it, it'll train everybody's then, or are those local customizations when you're?
This model is not trained. Everything you just saw is using a technique called RAG, which is kind of where you have, you basically just do prompt engineering as a way to think of it. But you do prompt engineering where you have a big pool of information that would be too big to put in the prompt. So you run like a local database, and you do the same thing that like OpenAI does with their embeddings. You basically compute the embeddings for all the tables up front. Those are local, for sure, because it's too much data. So we'll do a match first there to figure out the correct tables and the correct schema. Then that is what goes up to OpenAI. We're not specific to OpenAI either. We actually make it configurable. You can use any language model you want. Like I say, there's no training involved here, right? We're just basically giving you a prompt that's like roughly this big, a bunch of schema, and then a question at the end. And the prompt explains, this is what EQL is. Here are the terms you can use, stuff like that.
Thank you.
Okay, so let's build a dashboard. So you kind of, I mean, you've seen a couple of dashboards that we've built ahead of time. You can obviously, since we're talking about BGP peers, you can build your own. I'll just call this BGP peer. And I won't go through everything we can do here just for the sake of time. But I want to count BGP peers that are up and down. That's my use case here.
So this is like it's along the lines of a Grafana type thing, right?
Exactly.
Drop in different little things,
and you feed them with some data, and you have some customizability and like, do I want to show a total or a percentage, all that stuff. Kind of nice, very low code kind of environment to build dashboards. Very, very similar to Grafana. Here,
I want to add one that pulls in data from somewhere else.
Well, it's interesting you mentioned that. One thing we do, so there's a database underneath this, obviously, but it's in memory. We call it EDB. It basically lets you write to it from anywhere. So as long as you expose data to our database, and similar to like with Prometheus, you can get data from anywhere.
Like I can toss in something that's got some other metrics in there, with some other name that's obviously not clashing with whatever you've got, and I can just add
exactly.
charts, whatever it is.
And then you can query it using our query language and our natural language, obviously. So you get all of that for free. The other thing is, because it's now in our database, we can trigger automations off of it. So that whole event-driven stuff, as soon as it's in that database, you can trigger whatever you like. Like one of our very, very early internal demos, we had like HA proxy or something, which exposed a bunch of stats on a Unix socket. We had a little app that sucked on the Unix socket and then punted it over gRPC to our database, and then we could generate alarms based on HA proxy state and stuff like that. So hyper extensible is the story here. So BGP peers, I think I want to grab BGP peers and
I'm interested in like rate of change or something like that on it, received prefixes or something, but that might be a bit
too much. Rate of change. Yeah, so as I said, the rate...
Which ones are withdrawing and advertising too many prefixes, or where's some churn coming from a network, those sorts of things.
Yeah, so when we add the rate stuff, that stuff will be available. You can basically do a rate on any field, and then you can get like a standard deviation, and then you can obviously forecast notify when you go outside of that standard deviation. So I'm just going to create a BGP peer here. You see I'm just using EQL to query one of our resources there too. So I'm actually querying our default BGP peer resource. And I'm going to make up as green probably. And operational state is equal to up. That sounds good. And then we'll do down. Operational state is not equal to up. And we'll say that. Very, very easily, we have a nice little dashboard there. Now, we could keep filling that out. I'm definitely running out of time, so I'm not going to. But you can kind of see the end result is kind of what we had on the home screen here. So this is kind of our base home screen. You'll notice that we do things like there's no BGP peer information on the system dashboard because BGP peers come in through an app, and so they cannot possibly be on the system dashboard. You would have to build the system dashboard for that. So we've taken the whole decoupling of the core and the apps very, very seriously, right, to what goes into a system dashboard. Obviously, you can change this, right? If you really, really care about BGP peers, you can add them here. It's not we don't stop you from doing that.
It seems like that would be a good core add-on, right?
Yep.
Like I get the philosophy and keeping the hot stuff hot and the cold stuff cold, but we for this application we are running a network.
Yeah, of course, of course. So, I mean, everything you see there is very networking centric, right?
Sure.
Because these are all baked into our core. Like, interface is actually one of our core resources. It's not one that's added by apps. But you could imagine that this controller isn't being used for networking anymore.
Yep.
So the system dashboard doesn't make any sense if it's showing BGP. If you are an operator that only uses OSPF, even showing BGP here makes no sense, right?
Yeah.
So, again, we aren't too opinionated on what goes here. We just didn't want to tie you to any specific apps because then our core is now dependent on an app. That sounds like craziness to me. Yep.
I have an app owner telling me something stopped working. Can I grab a PCAP from within here? Or is that a plugin?
That is coming. The next thing I'm going to show you is going to be workflows. Okay. And that is we support that through workflows, yeah. Cool. So we have this, there's a nice segue actually to my workflows. Everything I've shown now is very kind of intent-based, very operation-centric, but there's some tasks that are run to completion, like an upgrade, right? An upgrade is not really an intent. It's I want to go from here to here in a very controlled manner with probably a bunch of pre-checks and post-checks, and after I upgrade, I want to do some stuff, and then I probably have canaries as well, and then I probably have the whole redundancy group thing that I showed earlier. So I'm going to use this actually as an opportunity to jump into, we've been using the UI up until now. Everything you've seen me do, you can actually do using our CLI. Either Kubernetes or we actually have our own CLI called e2ctl. So let me just generate a certificate here. So we can actually see get topo nodes. You probably, if you've used kubectl, this will seem quite familiar to you. We can get our list of nodes there. We can do the same for interfaces, and we'll get the list of interfaces. And note, you're getting all the operational state of all these things. You can get the exact same thing from kubectl, although the format's going to be slightly different. So you have kind of the access to sort of all the information via e2ctl or kubectl. And actually, I think in the hands-on this afternoon, you guys are going to play around with some of this. So we have these workflows, and I'm going to start with like a super, super basic one. Because the big thing operators want to do is just manage the CLI environment on their devices. So in SR Linux, we make everything very, very customizable. And we have kind of this, I'm just going to add this EDA managed thing to our toolbar here. So if I log into one of my nodes, and we'll motor through this because this part is not that interesting. You'll see here I've got current mode running. So we're going to change that, and it should now say EDA managed, assuming this workflow succeeds. What it's going to do is it's just going to deploy this to every node using gRPC. So it's going to use GNOI in this case. So if I go to my directory here, we can deploy this. And I can actually check that it's running here. It's actually already finished. So I log in again, and now it's EDA managed. Very, very simple, obviously. We just added some text to a file. Fundamentally, under the hood, all that did was copy a file, right? So you can do the inverse of this, obviously. This could be collecting error logs, for example. It could be collecting tech supports. It could be doing any of those kind of file operations you'd expect. We then have a CLI plugin install. So SR Linux is also crazy, crazy extensible. You can actually write your own CLI for it, and everything is available through state. So all I'm going to do is print what looks like an echidna. I promise that's an echidna there. So I'll come out of here again. Oh, actually, I'll go back in and I'll just prove that it's not there. So this is going to add the show EDA context, which doesn't exist. Let's go and add that now. Completed. So if I do show EDA again, well, actually I'll just exit out first because it's not going to be there yet. We now can print ASCII animals in our CLI. This is the real reason you make things extensible, right? Okay, so that's interesting, but not actually that interesting. Some other things we can do with our workflow engine is operational checks. Like this is going to be a basic ping here. And you can trigger this through the UI, obviously, where I'm just going to ping from a leaf. It's a ping. The ping type is node. We'll come back to that in a second. And I have an address in a network instance. I haven't actually changed this address. I just assume that there's something in the cluster that's going to respond to that. I suspect there will be. There was. Very good. So our ping was successful. But a single ping isn't that interesting. We have a bunch of extra information in our controller. This will actually validate every single inter-switch link. So it will ping across every ISL in the topology and make sure that they all succeed. I can run that. It's actually already finished. And that ran 36 pings, because we have 36 ISLs. And obviously it returns back, everything's okay. You can see the various pings that it executed. Another more complex version is actually doing the full mesh of pings between the loopbacks of all the devices. So we're going to ping every single address from every other address, obviously not duplicating work. And there we go. There was 28 pings that had to be run to do the full mesh, and everything is up, which is great. So you can do quite a bit with this workflow engine, copying files, running pings, rebooting nodes, kind of all the typical one-shot commands that aren't really configuration that you're applying to the device. Now we can have a look at upgrades. So I will, actually I'll jump back to our UI real quick just to show something. I've got my topology here. We're going to actually do an upgrade of one of the nodes here. So this is just to show you what an upgrade looks like if you don't care about all the pre-checks and stuff. So all you have to do is come into your node here. We're going to change the version to 24.7.1. And we're going to change this to 24.7.1 as well. And add that. Upgrade 1.1. Now we can actually dry run it. You can dry run even upgrades. In this case, not much is going to happen. The schema hasn't changed, but just for proof.
But if there were a schema change, you would catch that.
You would get a bunch of changes here. Exactly. Yep. So the main changes here are just to do with artifacts, because we're not using the 00 artifacts anymore. These are just the binaries we're serving. We're actually going to go and obviously move to using 24/7, and we can commit that. And we'll see immediately in my topology, my leaf 1.1 has gone offline, and the links to it have gone offline. So this is a sandbox, right? So it's very easy for me to just respin that pod using the new version. So in a minute, that will come back, and I can take a question or two if people have one.
Is there a safe mode? Like, are you sure you want to upgrade this switch in production at 11:55 a.m.?
I mean, we could add that, yeah.
Okay.
Or I don't actually think people will do upgrades this way, to be clear. I was more just showing you the mechanics of how you do an upgrade.
But to me, the upgrade is more around, I want to drain traffic from that. I want to have a complete workflow around that upgrade.
Yeah.
Yeah, that would be cool, huh?
Current state.
You can show us that,
light up.
Bruce?
You're really teaming me up here, Lindsay. Yeah, so this is kind of the mechanics. This is the actual thing that triggers the upgrade, which is changing the topo node to say you're running this version, not that version. We'll see that our leaf has come back up. But we want really a workflow to handle all the steps, right? Including, I should verify everything's good first. So go and run those ping tests, actually. Go run the ping ISL, go run the ping system, go make sure all the interfaces are up, go make sure all the BGP pairs are up. And when you're done with that, drain the node. So actually apply some routing policies, wait for those routing policies to sufficiently drain the node. And after that's done, finally go and kick the node. So we have a flow that does all that for you. And actually I have it here just so we can look at it.
There's a flow for that.
there's a flow for that. So this is going to do tranche-based upgrade. So I've got those 2 tranches based on those redundancy groups we saw earlier. I have 5 minutes. I need to kick this off like stat. So I'm going to go and deploy this. We can talk about it while it's running.
Redundancy groups in this context is things like MLAG pairs.
Yeah, yep, exactly. Either we can infer them for you based on the topology. In this case, I went and actually labeled the nodes. So I said all my odd switches are redundancy group A, all my evens redundancy group B.
You had kind of an unstated assumption that I might have dual attached hosts, you know, in A and B, and they're just not part of the model.
Yeah, exactly. Yep. So we can see in our topology that we just took down kind of the A side, including the spine. This will eventually all converge. While it's doing that, we can actually see what our flow is up to. Because this thing is actually going to kick off like a bunch of subflows. So it's kind of going to do the pre-checks, it's going to do the draining, it's going to do the maintenance, and we'll see here, it's actually already waiting for the nodes to recover. But what it went through and did was all those ping tests, it ran them all again. It went and checked that all the interfaces were up, all the BGP pairs were up. Basically, is everything in a healthy state ready for this upgrade. And when it was finished, it went and actually kicked off the upgrade. I'm going to keep scrolling past the pings here. So it actually done the dry run too. So this is kind of a safe upgrade in the sense that it tried it first using a dry run, and it won't proceed, obviously, if the dry run fails. If the dry run succeeds, it goes and sets the auto boot flag because we want to potentially ZTP the node. In this case, it's all simulated, so it actually will end up skipping that step. Then we have the drain. So it goes and drains the nodes. You would have seen like up above, I told it I'm only, like you can override the wait time. Either this could be based on you were at 80% utilization, you're expecting like an 80% drop, so 80% of 80%, like we'll compute that for you. In this case, I don't want to wait for that to happen because we'd be waiting a little while for the demo. So I just told it just drain it after 2 seconds. So it's gone ahead and done that for me. Then it skipped the reboot because changing the image would be enough in our simulator. And then it went and waited for the nodes to recover. And we'll see that it has gone and it's now finished waiting for the nodes to recover, and it's running the post checks. So it's going to wait for all the interfaces to come back up. It's going to wait for all the BGP pairs to come back up. And you can see what it's going to do next. It'll take the nodes out of maintenance because there's actually a flag we can set on the nodes to put them in and out of maintenance mode, clear the auto boot, and then it will actually undrain traffic.
That maintenance mode there, is that a flag from a monitoring perspective here, or is that actually, you know, ISAS overload type?
So we do the drain. We'll do the kind of like the control plane maintenance. The maintenance there is more a flag. We will stop commits to the node. So we'll say if any transactions are coming in towards that node, we don't want them coming in while the node's upgrading. So we'll just stop them.
So it's like from the controller point of view, this one's under maintenance.
Exactly.
It's on the controller side. It's not on the
exactly. The drain does the control plane.
The drain
side.
is the maintenance mode on the
exactly
itself.
Yeah. Okay. Yeah. Exactly.
Do you see the EDA tool being enlisted to know about impact on energy efficiency, power consumption, with changes in the data center fabric?
Yeah, I think anything that requires fine-grained telemetry in order to make decisions is, par for the course for this kind of platform. So computing power usage, figuring out that, we can actually shut down these Ethernet interfaces at night because the load is lower and that saves a little bit of power. That's all stuff this controller is capable of, yeah. We're just seeing literally the first version of this, right? We've been working on this for 2 years. What we've done here is build a platform, and we're showing you kind of the initial use cases that platform supports, but I for sure would say watch this space. We have done a lot in 2 years. And I suspect if you fast forward another 2, it'll be even crazier. So my flow here is going to go through. We actually don't need to wait for it to completely complete. Just waiting for BGP pairs to come up, and then it will eventually take these nodes back. But let's assume everything I've done up until this point was terrible. Like I really don't like how the network's operating now. I just really, really want to go back. So what we added when we talked a big game around GitOps, underneath the hood, everything I've been doing is tracked in Git, actually. We only have one database in this controller. It's Git. So everything I've done, as long as it was accepted by my infrastructure, I store that state in Git. And what this lets me do is it potentially lets me go back in time to any other moment in time. This is where the idea of being deterministic is really, really important, because it means I can literally step through my history at any point, and I'm guaranteed to get the result I want, right? So guess I should check to make sure that's all finished. Okay, good. So I'll bring up my other window here. It's kind of cool to watch the topology. So there's a few things that are going to happen. Obviously, I have a deviation here, but that deviation was kind of halfway through the demo. I'm expecting that to disappear. I installed an app, right? Our virtual network app was installed throughout the demo. That's part of a transaction, so that's going to disappear. I upgraded my entire fabric through tranches and canaries. It's going to revert the entire fabric back to the previous version. So I did this commit at the start, told the party starts here. We're going to go back to the party starts here. Now, we could give you a better warning there, maybe. But then actually run, yeah, it did. So you can see here, immediately, we went through and blasted all the nodes. We just literally reverted the entire infrastructure back to, I don't know, an hour and a half ago when I started this demonstration. So all the nodes get downgraded. The app would have been uninstalled here. I have no virtual network app anymore. If I look at deviations, gone. If I look at my fabric even, gone. So we wound back the entire infrastructure to an hour and a half ago. Now, because of kind of this deterministic nature, that was a 1.5 hour period, right? I like to make a joke that you might get to the end of the year and it's December and you're like, oh, things were great on the 1st of January this year, and just wind everything back to the 1st of January this year. That is something this controller is capable of doing. And that's kind of it. That's all she wrote.
So many questions. What about if you have multiple data centers?
Oh, of course. So the concept of a fabric really is a single data center. So EDA itself doesn't really care about the physical topology. We actually envision this, I mean, leaning into that whole scale angle I was talking about and why being event-driven matters. We want you to have a single instance that manages all of your infrastructure. So obviously that's one deployment model. We don't prevent you from saying an EDA instance per data center too. That's okay. We won't stop you from doing that. But it's a little bit up to you. This thing will scale up, so it'll manage all of your infrastructure through a single platform based on its architecture.
And the controllers, are the controllers VMs? Do you require 3 for a quorum?
Again,
an appliance?
It's a risk tolerance thing for you. So we recommend a 3-node Kubernetes cluster, obviously. We provide a packaging model where we will give you VMs for the Kubernetes cluster. You can also onboard this onto any cluster you have. So if you have an on-prem cluster already, it's not a problem. We kind of made a point, actually, of being truly cloud native. You can run this controller everywhere. It's not using any underlying infrastructure. It's not using a specific storage backend. It's not using anything special. So you can run it literally anywhere where you have a Kubernetes cluster. You can also, if you don't care about redundancy, you don't need to run, like I'm not running 3 controllers here, right? As I said, this is running on my desktop upstairs. There's not 3 of them. So I'm deciding that everything runs here locally. Obviously, if that guy goes down, my controller goes down. We do support geo-redundancy as well. So you can actually have 2 controllers work on quorum, and they can be any size. They can be 3-node clusters, 5-node clusters. It doesn't matter. That's a question of scale more than anything. So you do get the redundancy if that's what you want. But again, these are all, at the end of the day, up to the guy deploying it. What is his risk tolerance? How reliable does he think his power is? All that stuff. And is he okay with the controller going offline? Because it's not like the switches go offline, right? They still have the existing config. Everything's still working. You will just lose visibility.
Interested in how Nokia measures that EDA can save customers operational effort up to 40%.
Yeah.
And I guess, how is that, measured? How does a customer know, okay, Nokia, you're delivering on that?
So what we did is we have Bell Labs, obviously. We gave them the task of going through a bunch of the typical things a data center operator would do, like upgrades, for example. You can imagine doing that upgrade manually, right? That is multiple nights, probably, and like hours and hours and hours of work. So we gave them a set of tasks, and we talked them through what our product was capable of doing, and the way a typical kind of field engineer would do this if he was on the CLI. That's where those percentage numbers come from. So there was an actual study that was done. The numbers are grounded in some degree of reality, for sure.
Fair enough. And would it be dynamic, like, okay, a customer adopts it every quarter, hey, EDA saved you X amount based on your profile?
Yeah, so we do plan on kind of enriching this transaction thing a little bit more. Right now it's very much, this is what I did. We want to convert it into I pushed this many lines of config. If you were to do it manually, it would have taken you this much time. We want to do some of that just as like to drive home, you're getting a ton of value here, a ton of value. So we will do that. Right now there's not much baked into the product that does that.
All right.
When I saw how easily you drain traffic and upgraded the code, I got a little mad.
I mean,
Because
yeah,
of
we
the
were talking
countless hours I've spent and nights and
yeah, we were talking to Lindsay last night, and he was telling us the story of just, I mean, the perpetual upgrade cycle, basically.
it never ends. And it takes forever. And it's awful.
I think this is a really interesting example of all the automation that's gone into generating configs, and now seeing everything else I can do, now that that lower level work is automated, I can actually spend my brain cycles on, well, what could I look at?
Exactly.
And no one prompted me to say anything like that. I mean, that's just genuinely how I respond to this.
Yeah, I mean, the idea is that this takes care of some of the nitty-gritty of rolling out changes to infrastructure, right? The part that's really hard, the idea is that you can spend more time designing infrastructure, like where do we need to evolve, stuff like that. So yeah, the idea is this frees up a bunch of time for you to focus on what you want to do, not necessarily what you have to do.
But I could easily see those cycles being sucked up by, oh, wow, I can go interrogate this, and I can try to visualize this. So, yeah.
I mean, it's definitely a sandbox, for sure.
Sure.
But it's everything you showed is how the product works out of the box, right? So it's one of those cases if it's really designed on that spectrum. You can get into the weeds if you want. You can design your own dashboards. You can design your own apps. You can take our Python, modify it. If you're that style of user, have at her. But we also need to cater for the guy who just wants it to work, who doesn't really understand networking too much, but he operates a network. So he just wants the point and click, it must work, and tell me when it's not working. So we have to cater to both spectrums. I like to think, and I am paid to say this, we did, right? We did. We've covered both ends of the spectrum. It's turnkey as well as insanely flexible. Okay.
You showed a lot of the configuration was you typed in here or copied from a YAML file and pasted in. What about plugins to IPAM systems or other sources of truth for device names and things like that, like a Autobot or a Netbox or?
Yep. So we have two modes of operation for those. One is you allocate a prefix in like Netbox, for example, and then you tell us what the prefix is. We want to be the one allocating. Because of all that deterministic nature, the idea of rolling back would be impossible if, as part of that rollback, I had to go to an external system and say, oh, please give me an IP, and please make it the same IP I had last time.
Right.
We cannot possibly do that, right?
So the model is Netbox has the prefix, you assign all the individual IPs.
Exactly, yeah. And then we can still publish back to Netbox and say, I've allocated this, I've allocated this. So you can still keep the synchronization. We just want to be the ones doing the actual allocations.
Yeah, that makes sense. I was just looking at ways to save the double typing. You know, you enter it into this system, but you also got to enter the prefix here. And,
Yep. So we can sync with Netbox. I mean, the product doesn't do that today, but I mean, very easily we could sync with Netbox and say, oh, there's a new prefix, and it's characterized in such a way that I know it's for me, so I will automatically create my local allocation pool for it. We can definitely do that kind of stuff.
So are you syncing with Netbox, or are you using Netbox as your source of truth repository of record?
I would say we're syncing. It's the one defining the prefix. Okay. We're the ones populating the allocations within the prefix and then syncing those back. So it's the one telling us you are responsible for this prefix, but now we're authoritative. We're the source of truth for the allocations within that prefix. We would just expose them back to Netbox so that it sees, oh, I see that you allocated that. And so your source of truth kind of like looks the same from a Netbox standpoint. Okay. But it's not really the source of truth for the addresses within the prefix, because we're the ones allocating them.
Yep.